So thank you very much for coming to our first session of oral presentations. And our first speaker is going to be Casey Kennington, who's going to be speaking on natural language processing for computer scientists and data scientists at a large state university. So please, the floor is yours.
Right, thank you. And thank you to the organizers for this great workshop. I'll just jump right in here. There are many reasons why people are jumping into natural language processing. Maybe they want to do research. Maybe they just need natural language processing for their own research or for their own work, but it's just an expanding field. And I really think that students from various backgrounds can and should be exposed to the aspects of natural language processing. The question is how, and I've really considered that at the university where I work, which is Boise State University. It's the biggest university in the state of Idaho in the northwestern United States. There are about 27,000 students here. I'm the only proper NLP researcher, so it's kind of on my shoulders, but like I said, I want to make it accessible to different people, not just computer scientists, even though I'm in the Department of Computer Scientists. So here's kind of what we've done. Students, at the very least, need to have what we call computational thinking. And that's correlated with programming, but not quite the same. So data scientists are people who have taken data science classes from all fields, which we offer here. And computer scientists are pretty well prepared for a natural language processing course. And there's two ways to get here. So the natural language processing course is kind of over here. Computer scientists go through their usual kind of 1-2 data structures courses. And then there's a programming languages course, which I teach, and it actually covers context-free grammars. And that is really nice as a prerequisite to the natural language processing course. The data scientists start with a 100-level Intro to Python and Statistics course. We borrowed the content from Berkeley's Data 8 course. And then they go all the way through a machine learning course that doesn't include any deep learning. And these students are really well prepared for the natural language processing course that I teach, which is at the upper division undergraduate, and it's also dual listed for graduate students. It's about 2/3 undergraduate, 1/3 graduate. These are kind of the areas I've identified that we cover: linguistics, probability information theory, machine learning, programming, and applications and tasks. And if you come into this class with some background in two of these areas, you do well. And data scientists have to, computer scientists have to, and we cover aspects of natural language like finite syntax and semantics, how they can be computationally processed. We give a survey of models and approaches, and we help the students gain experience with some natural language processing programming libraries. The books we use are the Jurafsky-Martin book. I say 3rd edition. It's kind of the being edited on the fly right now on a website. Updates are happening all the time, and the NLTK book. And we chose these two because they're free to the students. They're online. The course content, probability and information theory is where things get started, because when I took my first NLP class, this is where I crashed and burned. I really struggled with this stuff. So I have some Jupyter notebooks that cover discrete, counting things, continuous probability distributions, so fitting parameters, and of course information theory. Another thing that's different about natural language processing compared to a lot of machine learning is modeling sequences. Machine learning, generally people think, well, I'm mapping from a set of features to a distribution over class labels, but sequences are really important in language, whether it's spoken or text. So we do cover HMMs, and we do cover part of speech tagging to move them into the direction of sequential thinking. And decoding is really important too, because you're not done just because you have some probabilities distribution over labels. You need to now step through them and decode. Syntax, we do a context-free grammar parse of Tamarian, and the students love this assignment. It's not a machine learning assignment. They just have to write the context-free grammar. And if you're not familiar with Tamarian, it's in Star Trek: The Next Generation. It's not a whole lot of speaking there, but and it's actually English vocabulary, but very bizarre grammar. But they love this assignment, and they just have to write the CFG. The semantic stuff I cover probably the most. There's a little bit of formal, a lot in distributional. So we do talk about embeddings a lot. I lump language models into this because they're derived from text. And then there's grounded semantics, so visual grounded models. And this is where the students really love to discuss language and really get philosophical about what meaning is. I really love the discussions with students at this when we talk about meaning and semantics. Of course, we talk about libraries. There's a whole bunch of them now. When I first started teaching, it was scikit-learn and NLTK. Now it's take your pick. We give kind of examples of everything so students can use them in their final projects. As an aside, I've noticed that data scientists do well with TensorFlow and Keras because you can get away with not knowing about data structures, whereas with PyTorch, you have to extend a lot of their classes. So computer scientists do well with PyTorch. And then we do machine and deep learning. Deep learning is the second half of the class for the most part, and we cover multilayer perceptrons, convolutional neural networks, and transformers, which requires a little bit of RNNs. The reviewers for my workshop paper here really liked the themes. There are two themes in this class that come up all through the semester, and one theme is the theme of ambiguity. And you know about ambiguity. It's hard to recognize beach versus hard to recognize speech, or kids make nutritious snacks, or every person loves a cat. Like, these are all different types of ambiguities that exist in language, and ambiguities are everywhere. And arguably, ambiguity is one of the reasons why NLP exists as a field, because we're trying to deal with ambiguity. And understanding ambiguity helps them understand linguistics, and it helps them understand what the problems are that we're trying to solve with natural language processing. The other theme is the theme of limitations. And this builds from the theme of ambiguity in a lot of ways. But I mean, we can approach language processing, NLP, in a lot of different ways. We use probability theory, we use machine learning, data-driven techniques, we use strange and unusual and very clever training regimes like masking. But what are their limitations? What does that mean when you train something completely from text? What's it missing? Or if you use probability theory to model some sort of language phenomenon. And this is where an assignment that Emily Bender mentioned in the panel this morning, critical reading of popular press. I tried this out this last semester. It was really nice to showcase the theme of limitations. I had students look at popular press articles about kind of the latest and greatest research that's happening in NLP, and really look at them and find the limitations of what they were reporting on. And the theme of limitations naturally leads to discussions on ethics, because throughout the semester, if this is limited, like if the data or the model or the training regime or the task or the metric have limitations, what does that mean? Who does that affect? If if someone trains a speech recognizer on data that's only trained on adult kind of male voice, native standard English speakers, it's not going to work very well for women or children or people with accents. And we need to point that out throughout the semester. At the end, there is one lecture that kind of brings it all together, but ethics is kind of an ongoing discussion that's based on limitations. To deliver the course, it's mostly Jupyter notebooks. There's one on discrete probability theory, continuous probability theory, and this is important because if they don't understand like a joint distribution or a conditional probability, what chance do they have of understanding like what a loss function is doing or what cross entropy is doing, for example? So we do need to go through this stuff, or we do HMMs, and they do that because if you understand HMMs, it will help you understand these generator discriminator models that we have, these deep learners that we have. We actually in class together program a naive-Bayes classifier, first discrete and then a continuous one with a different set of data. We look at code examples of context-free grammars. I have a notebook that takes the students all the way from linear regression to logistic regression to convex, non-convex optimizations, all the way to multilayer perceptrons. We look at BERT fine-tuning, tons of code examples for the students to look at. The rest is lecture slides. I use Trello for the website, which I'll show you in a moment. And okpi.org is where I have the students submit the notebooks, and that's where I grade them. It renders them nicely, and it's a pretty easy way to manage submissions. And then they have a semester-long NLP project that they propose mid-semester. They write a 4 to 6 page report at the end of the semester, and grad students have to give a presentation. And not half the time, quite a bit of the time, the students crash and burn. Like the thing that they thought they were going to make work didn't, and they learn a lot from that. I think that's actually an important outcome. So this is basically the entire semester from spring 2021. We have a Trello board here. It has all the admin stuff like syllabus, link to the Zoom. Lectures and topics are all here, and I just kind of piecemeal add them as the semester unfolds. Assignments, same thing. You'll notice everything has a due date. quizzes in the project, all the different aspects of them. So the assignments are all right here. To introduce Python and Jupyter, I actually have them open up the NLTK book and write by hand code from 2 of the chapters. It's really insulting, but they get a lot from it. And then there's probability and information theory for counting stuff, parse speech tagging, of course, with decoding. This linguistics is the syntax assignment. Topic modeling introduces them to multilayer perceptrons. Keras and TensorFlow. Transfer learning introduces them to convolutional neural networks. And that leads into grounded semantics. And this is the first time they use a bigger data set, like a 12 gigabyte data set using the RefCoco MS-Coco data set. And then there's a BERT fine-tuning assignment with a novel task that's not found online. So they can't quite find the tutorial and cheat. And then the critical reading in the popular press. Some reflections. Things have gotten better over the years as we've pushed Python learning down in the undergraduate learning into 100 and 200 level classes. At this point, most people know Python coming into the class. They have some background with context-free grammars and some degree of experience with machine learning and deep learning, which is great. So I can focus more on the language stuff. So to conclude, it's not easy to stay up to date on this stuff. What do we cover? How soon? Should I wait? Data science students are still struggling a little bit in my class, but I think it's important to keep it open to them. And when I say data scientists, I mean anybody who's just taken data science classes. These students are potentially from all different areas across campus. When the course is over, I want students to know that they aren't experts, but they have a solid start, based on, kind of extending the limitations thread to themselves. I have 100 other things I could say, but we'll just stop there and thank you for your attention.
Well, thank you. That was terrific. And we do have time for questions and discussion. And
I see people's hands up in the participants thing. Should I just
excellent.
call on them and go?
Yes. Why don't you?
1,000 times.
Excellent. Please go ahead.
So Margot, I guess you're first.
No, I was actually just applauding, and I'm
Oh, you're
trying to
applauding.
switch
I
that
see.
off.
Those aren't hands off. Those aren't hands up. Those are applauding. So if people do have questions,
yeah, if you could either raise your hand or put a little cue in the chat or some signal. I guess. I'm sorry.
Well, that Trello board that has some of my course content on it. It's actually a public Trello board that people can look at. And the link to it is in the paper if people are interested. So the notebooks I used are linked to the Trello board.
Yeah, I highly recommend that. That's really neat. I was looking at that, and it's really a terrific way to organize content. And maybe let me throw a question in, and I think you kind of started to address it. You seem to have these 2 streams of students coming into your class. One sort of a CS machine learning background, or data science machine learning, and the other computer science programming background. And you kind of alluded to the fact that the data science students might be struggling a little bit more. And I guess I'm wondering if you could elaborate on that. What about their backgrounds or their interests or something else may account for that?
Yeah, it's a great question. It's probably less about their background and more about my bias. So my background is computer science. My background, and I'm in a computer science department, so I'm used to teaching these students, and I know what they come to class knowing. And the students who are from across campus, I kind of take for granted that computer science students know certain things, and I might use certain jargon that the data science students don't know. So that's something that I have to fine tune more on myself, more than the content, I think, of the course. But that's why I keep TensorFlow and Keras, even though the trends are kind of moving towards things like PyTorch. I try to keep that in there because I think data scientists respond to that better. The PyTorch stuff, I want to assign them something and give them some exposure to it, but then they have a choice. They can say, you know what, PyTorch isn't for me. I'm going to stick with TensorFlow Keras or both if they want to, but that's why I leave it open.
Yeah, I mean, I think that's been certainly one of the themes dealing with these different backgrounds. And we have a question, Mannix, your hand is raised. Please go ahead.
Thank you very much, and thanks for the nice talk, Casey. I really like the talk. I have so I don't know if it's a question or suggestion or maybe something to think about, but as I understood from your talk, one of the struggles for data science, and it's also related to what you were talking right now, like the struggle that data scientists may have. And it sounded like data scientists may have more struggling, like when models that make use of data structures, they may have more struggle with this kind of cases where they need to use things that require knowledge about data structures. So maybe what do you think, would it be a possibility having maybe a 2 weeks crash course about data structures before starting teaching?
That's a good suggestion, but I don't know. I have some philosophical arguments against that. It's almost like a 2-week intensive course in linguistics would help too for the computer scientists for the same reasons. Yeah. I'd rather just pull it out. So like when I first taught the HMM stuff, I was saying like, let's use data structures. And then I backed off and said, actually, let's not. Let's use existing data structures that come with Python instead. And so when I give my code examples, the only time I'm writing my own data structures is when I'm extending stuff from PyTorch. So we could do that, like show a class, something like that in Python. And I do that when we get to the PyTorch stuff, but for the most part, I try to avoid that. If students really want to get into that, they can get the CS minor, and that's enough. But yeah,
I see
more to add, yeah, but it's a good suggestion.
Well, that's terrific. I guess we should go ahead and thank Casey again, and with our kind of virtual applause, and we'll transition over and do. Verada was kind enough to post a link to the Trello board in the chat. I strongly recommend that you visit that and check that out along with the paper. And thank you very much.
Thank you.
And so